I worked for 2 years at Terracotta. Terracotta is a distributed cache cluster and everything. And that's where I learned a lot of stuff about caching and which concepts you can have around it. So first of all, just the basic. I suppose that everybody here knows what a cache is. Does someone don't know what a cache is? Okay. So a cache basically is just a way to make the access to your data faster. Okay. So for an application cache, we put the data in memory. Why? Because it's fast and it's kind of cheap. It's not really cheap, but it's a good balance, okay? Why having something in memory instead of this? For that, it's speed. I like that slide because you can see it's a time scale of system latencies. The CPU cycle is 1 second. It's just a time scale. And if you see SSD, it's around 2 or 6 days, between 2 and 6 days. And if it's an old school disk, it's between 1 and 12 months. So you really see that having stuff on memory is really, really faster than having it on disk. That's why we try to do that. So some vocabulary, okay, what is a miss? It's just when you ask the cache for, like, say, give me the X key, you say, okay, I got it, and I give it to you. And the miss is, I don't know, what do you want exactly, and I have nothing in me, so it just says it's a miss. I will do that later. So, the basic is you have a web application or basic application, and you just want to improve your data access. What you do normally is what we call cache aside. Okay? On cache aside, if you get a hit, oops, in fact, a cache aside is where your application is responsible for reading and writing from the database or any data store you have. Okay, the cache is really separate from the database. You have no interact directly between your cache and your database. Okay, that's why we say that the cache is kept aside. That's why a cache aside. It's a faster and a scalable in-memory data store. Okay. So the algorithm instead that is just you check the cache. If you get the key, if it doesn't, you go to your data store and do some SQL stuff and stuff you want. If you get, it just returns the value. Okay. So for the first access, it's slow. Why it's slow? Because the cache will say, okay, it's a miss. Your application say, okay, I realize the database to it. The database will do the request. You use info, you will create an object, you will put it on the cache, and after that you will say, okay, let's continue your work. Okay? So that's good, because for every second and after access, you will have the data in cache. So you will be really, really fast, okay, in serving the data. But you get two APIs. You've got one for the cache, one for the database. Okay? So for reading, you will be really efficient. For writing, there is no really difference. No improvement there. What's good is that if you look at your database load, it will be decreased, it will be lower, okay? Because most of the time you will deal with the cache and never go back to the database or data store. What you can have is some trouble with invalidation. I mean that you do your request, okay, an object, let's say X1 version 1 is put on the cache. Someone updates the database, okay. Your application will keep asking the cache, so you will have the old value, okay. In most of the use cases, that doesn't really matter. Sometimes it's matter. So what if you want to really have always updated data? just to be clear, most of the time you don't want to, because when you do cache, it's really because you want to be fast on price, okay? And most of the time you are okay if you have a small desynchronization between your database and your cache. Sometimes you're not. That's why you've got other concepts to use. And the first one is use the cache as a system of record. Are you primary system of record? For the cache aside, you've got your main data store, database, stuff you want, and you've got the cache aside, okay? Here, when you use the cache as a system of record, your cache is the main system, okay? The other, database or stuff like that, is secondary. That's a secondary. So, to use it as a system of record, you will always interact with the cache and never to the database. You will train your cache to interact with the database, but you, as a web application developer, probably when your application interacts with the cache, it will only interact with the cache. So, sorry for the animation, I don't know what's inside. Okay. So, the reach room. So reach through, it's really when an application asks for an entry, okay, for example, key X and X is not in the cache, it's the cache who will add to the database, he will have the return from the database, he will compute the object, he will put the object in cache, and he will return to the application. So the good stuff in that is that you can't have any desynchronization because everything goes through the cache. So the cache has always the latest value, okay? You will not be faster because in fact you did not improve anything except that going through the cache, going through the database, giving back to the cache, giving back to your application. So it's as speed as the cache aside, okay? But it's good, it's better, it depends on your use case again, but it can be better because you always have the updated data. For the right, it's kind of the same. When you do a put on your cache, it will you will have trained your cache to be able to update to the database. So on the right, again, it's good because your cache is the primary system of record of your application, but you don't gain really anything, okay? It's even a bit slower because you go to the cache, to the database, instead of going directly to the database. But again, we're doing cache. So if we do a cache, is that we just want to improve the read, okay? Right? Most of the time, it doesn't really matter. Think about an e-commerce website, okay? Most of the time, user read it, and you don't have to modify each milliseconds the price of an article and stuff like that. So the write you do on your object, it's maybe less than 10%. It's just, yeah. So because it's really improved and built to improve the read, the write doesn't really matter. It matters, but not that much. Okay. The problem with the write-through is that, in fact, we can do better. Someone can think about something who can make stuff better. Write-through is synchronous. So if I want to do stuff faster, what can I do? To do just that, the same thing, but asynchronous. Okay? Okay. That's what we call right behind. Right behind is a write-through asynchronous. Sorry. Okay, sorry. My office crashed this morning, so I just tried to do everything on OpenOffice, but it doesn't have the same. So right behind is just a write-through asynchronous. What you gain here is really on write, because no write, it's immediately. I mean that you have the application just say, okay, put that in cache, and the cache say, okay, I will do it with that after. Okay. What goes with that is that, so write are really fast, and you will think I've got some data to show you. But what's really good with right behind is that if you I think that everybody knows that your database prefers when you do a big request with a lot of kubernetes than a lot of small ones, okay? And that's really what you got with while behind, because you can say, okay, you flush everything you have to update in the data store maybe once an hour. So every hour you will update the database with optimized big requests. And when I see optimized, I always think that you can deal with completion. Okay, completion is what, for example, you get an update on key X 1 time, 2 times, 3 times, 4 times, 5 times. If you do that with while behind, in fact, it will always be the latest one that will be put in the database. Okay, it will detect that you have the same update on multiple it will detect that you have multiple updates on the same key, and because it's just a key value store, it will always take the last one. Okay, so for your database, again, it's better. Of course, you will have again a synchronization between your database and your cache, because your cache will have the last value and your database can have all the value. Okay, so think about what's happening if you get a crash, if your cache crash, what you will do. Okay, other stuff that can be good. If you get a use case where you get a high peak of user at the same time, you can use while behind to say, okay, here I get a really peak, really a lot of writes. Let's do that a bit later. Okay, and in that way you can normalize the way you deal with the write for your database. So your database will really be happy if you use while behind a good way. Okay. Again, so for the access time between the two, that's for a write-through response time, because that's a graph for coherence, but every cache will do things the same. Okay, you'll see that with a write-through, you get a response time between, let's say 400 milliseconds, okay, for the read, for the write, and for the read it's kind of immediate, okay. We have between 2 or 3 or 4 milliseconds, that's kind of good. For the write, you see that 400 milliseconds is kind of a sensitive time, okay, you can feel it. And of course, if you see while behind, because it's asynchronous, it's immediate, okay? Every read and write are between 0 and 5. You get some peak, but even a peak at 20 milliseconds, it's nothing compared to a 400 millisecond delay. Okay. And what is really interesting too is how will my database will be loaded. Okay. So that's when you do write-through, that's the database load. You see that it's not really high as CPU. It's between 6 and 8%. Okay. It's kind of big compared to what you can have with while behind. Okay, that's while behind. Why? As what I told before, I mean it's really because you get you can do big requests. Okay, so your database will really be happy. Your network too will be happy. Everything will be happy if you get the good use case to deal with that. Okay, not all use cases fit with the while behind. Right. So the deal with while behind and while through and with through is that it supposes that every change you do to the database, you can handle it. I mean, that's your web application. If you get in a big company, like financial or telecommunication or stuff like that, sometimes you don't own your own data. Okay, that could be another services who will do some batch and stuff like that, and who will update your database. Okay, if they do that, you can't use retrieve write-through because you don't handle your data. Okay, that's another service who will update the database. You will not tell your cache. Okay, so what's happened if you want to be speed and you can't really control the data? So just for the notes, do you know the GSR 107? Okay, that's the GSR for the cache. It's kind of not really old GSR, but it's pretty new because it's just finalized. You only have write-through and read-through on it. Okay, every step I will speak instead of these two, it's not on the GSR. But if you use a good cache, it will provide you that. Every cache manage some differences to provide kind of the same features. Okay. The first one is inline refresh ahead. Who knows? Refresh inline refresh. Nobody? Okay. With refresh ahead, you suppose that you want to be really, really fast. Okay, think about a company like Amazon, who know that if the guy who prints page, who has access to use the website, waits a little more, the deal can vanish. So refresh ahead is really to try to improve the best we can do on the read. For refresh ahead, you've got 0, so that's a timeline. You get 0. You got TTL. Who knows what TTL means? What? Yeah, time to leave. Okay. Time to leave, watch it, is just you say, okay, my data, you put the data in cache for, let's say, 5 minutes, and in 5 minutes, she disappears. Okay? The way you do that is none of your business, but you know that, that's the time to leave. Okay? Here is something different. It's time to refresh. Okay? It's really to be the faster you can and deal with the most updated data. What does I say that? Between 0 and time to leave, your cache will have the value, always. Okay? You ask for key X, it's in the cache will return it. But if you are before time to refresh, nothing happens. If you are after time to refresh, magic happens. By magic, I mean that on the background you will have a thread, okay, that will say, oh, okay, someone tried to access that data after the time to refresh, so let's refresh it. So in fact, you will have on the background a thread that will refresh for you all the data that have been accessed after the time to refresh. Okay. Imagine your application asks for the key X on the exact time for the time to refresh. Okay. We will have the potentially an older version, okay, but just after the thread, the background thread that does the refresh, do the stuff, you will have an updated data at no cost. Why at no cost? Because everything is due in background, okay? So that's kind of, that's not hard to it's time to refresh ahead is something simple. We use it for many years, but it's really interesting because you don't have any cost. You visually have no cost to have updated data. Okay, everything is done by background threads. So for reading, you can be really efficient and have sort of really updated data. But the problem with that is that, okay, that sounds like magic, so why everybody not use that? It's because if you don't understand what it is really, you can apply that concept on a bad use case. And if you do that, that can be really a bad idea. Why? Because you get the thread doing all the you get the background thread doing all the access to the database. And in fact, if you do not have a proper use case, you will just overload your database and your network for nothing. I mean that if you don't have really the need of that, just remember that you will have some some overload of all your system behind the cache. For example, if you only have access to a data on a short time, and after that no access to the cache, if you put your refresh ahead on the same, the time to refresh, on a bad time, okay, you will do access to your database for nothing. Okay, so that can be really, yeah, I did that because we see customers that do that really in a bad way, and on a bad way, you will see that there is not a lot of improvement. If you don't see improvements, you get a problem. Okay, maybe use another concept or other stuff, but not that one. If you do, it will be really, really fast. Okay, really. Another thing that I like and I think it's cool is called, if you work in the phishing side, sometimes you know that at maybe every hours, okay, at the beginning of every hours, you will have a huge updating of your data set. Okay, you know that because most of the time it's batch. Okay, so if you work with batch, think about what we call a scheduled refresh. Scheduled refresh, and that means that if you can predict that you will have a peak every hour or every 5 minutes or every, I don't know, every 15th of the month, that can be perfect. What you just do is that it will scan all the data, all the keys you get on the cache, and it will update them. Okay, each one. So again, if you don't need it, that can be really poor performance because it's really high data exchange between your database and your cache. Okay, so but if you really do need it, that's something that is not used because you do not always deal with batch. But if you do, it's really interesting to see that you get other stuff that just the cache aside that everybody knows. You get also other concepts. And that's pretty refresh, so it only works if you get a time issue, like batching or stuff like that. So who do I choose? Between cache aside and read write through. That's kind of easy. Cache aside, you have two API, and you really want to deal with your cache as a secondary system of record. Okay. Read write through, it's really to have updated data, and you can have the something I didn't say. When you get with write behind, okay, you remember write behind is like asynchronous read through, write through. You will really have to deal with failure on your system, because if you get maybe 2,000 of keys updates on your background thread, and everything fails, what you should do. And in fact, most of the system will provide you some methods to say, okay, let's try that every hour during 7 hours. And after 7 hours, you just quit and you lose all your data. But most of the cache will provide you stuff to handle with data failure, with network failure or machine failure. Okay, so just like that. So yeah. Refresh, inline refresh ahead and schedule refresh, the other one. It's really, can you predict how your data is handled with the time? In fact, what you have to do when you try to optimize your cache is not to optimize your cache at the first second. Just take a pen, you take a pen or take everything you want, but you just try to see what is your data like. Okay, how many times are updated, how many times are deleted, how many times are read, how many times are write, what's the ratio between reads and write. Can you find some timer, some peak on that? Can you have outdated data or not, and stuff like that. So really, what we can see when we do cache optimization is kind of the same as the people who do JVM optimization. In fact, you just have to not do that too early. Okay. First of all, you have really to know the data you manipulate and your system and all the interact between your web application, cache, and database before trying to deal with another pattern. Even if most of the time, the problem is that most of the time the clients we're going in say, oh yeah, but the first time we use that pattern, for example, I don't know, right behind, it was kind of super fast. Yeah, it was kind of super fast at the first time, but 6 months after, it's not that fast because in fact your use case doesn't fit really well with that concept. So first of all is really to understand what is really your use case, what is really your data. The difference between refresh ahead, inline refresh ahead, and schedule refresh is really if you've got one is time, okay, you just put a cron string on it and say, okay, let's update all your data at a given time. Inline refresh ahead is no in a timer way. Write behind and write through is really, one is synchronous, so synchronous is good, but it's slow as always. Because you will have the last updated data, but it will cost you a lot. Sometimes you don't care, sometimes you care. If you care, just go to write behind, okay? Because it's asynchronous, it's fast. But write behind, you will begin to deal with a network failure, machine failure, and everything that can fail will fail one time, okay? Because when you use distributed caching, most of the time is not on 2 and 3 nodes. Okay, it's kind of bigger system, so you learn to deal with failure every day. So with while behind, sometimes it can be a little tricky. It's not hard, but you have to think about it. So my conclusion was just to be into really, when you try to do cache optimization, so what I present to you today is most of the pattern we use when we try to really speed up our cache. But again, don't try to speed up your cache if you don't really understand what the life of your data is. That's really, really important. So my conclusion will just be know your data. Does someone have a question or? Okay, great. So thanks everyone.